So in this video we're going to look at the electromagnetic spectrum. So I mentioned previously how light is an electromagnetic wave, and visible light is the spectrum of electromagnetic waves that we can see. So this is the small part of the electromagnetic spectrum. So what are the other parts? And this is an example of visible light I've drawn here, as from our previous example in the last page. So the electromagnetic spectrum is continuous. By that I mean that any wavelength possible, you can have electromagnetic radiation with that wavelength. There's no forbidden wavelengths, all are acceptable. So from 0 all the way up to as long as you'd like. But we usually divide it up based on wavelength and give particular groupings a particular name. As to say, from a certain wavelength to a certain wavelength, we call a particular type of electromagnetic waves. Even though really there's no actual distinction, they blend naturally into each other. It's useful for us to be able to divide them up so we know what kind of waves we're talking about: long wavelength, short wavelength, and we'll see later how that relates to energy. So we're going to do that by wavelength. Obviously that's equivalent to doing it by frequency, because we know that wavelength and frequency are related by this formula from the last video, that either lambda is your speed of your wave, in this case the speed of light, divided by frequency, or the frequency is the speed of light divided by its wavelength. So let's just fill in this table we've got here. So we're going to say the type of the wave, and then what its typical wavelength ranges are. So the longest wavelength rays are radio waves, and these have a wavelength greater than about 0.1 meters. And these are what we use for satellite communications, etc. For televisions, for radio, that kind of thing. They're very, very long wavelength rays, and there's a bunch of reasons why using those are better for those kind of communications than using a shorter wavelength wave. And then the one after that is microwave, and that's from 0.1 meters to about 1 millimeter. So obviously we're going down. And anything inside about that kind of wavelength, which we remember is big, right? We're going from 1 millimeter all the way up to 0.1 meters. So that's a millimeter to 100 millimeters, basically. That's the kind of range we're talking about. And obviously we're familiar with those from microwaves in our homes. The one after that is infrared. And this has an even bigger range, going from 1 millimeter to 700 nanometers. Now a nanometer is 1 × 10⁻⁹ meters. I've just written that there at the bottom so we can keep that in mind as we go across. So we're going from about 1 millimeter to 700 nanometers. Now infrared radiation is the radiation given off by things with a temperature. So kind of anything with a temperature emits infrared. In fact, even ice cubes will emit infrared radiation because they still have temperature. As things get hotter, they start to radiate energy in the visible light, but most things will radiate their heat in the infrared. That's where the majority of things that aren't too warm will radiate their warmth.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.